I'm going to present how all the part of machine learning operations in Databricks and MLflow using Databricks platform and the integration with MLflow. So the agenda for today, first of all, I will introduce the project with which I implemented these processes. Then we will go through all the stages from data preprocessing, feature engineering, model training, model deployment, model testing, and then we will see what next steps we could do and to improve and to go further with this. I will go back and forth to to Databricks, so to show you where everything has been implemented. So to start with, the project with which I'm going to show you is related to Visin. Visin is for those of you that don't know it, is a public bike renting service in Barcelona. We chose this because we have public accessible data since 2019, so we have quite a lot of data, and also we have an API for live data. So the goal is to predict the bike station's utilization rate. So to start with, we have to get the data from Visin. What we have is zip files with CSVs. So the first process will be to unzip them and convert the CSV to a format which has better performance for processing. In Databricks, we start with we will start with the catalog, in which you could have many different data sources. In our case, we are going to use the default one, and we are going to use the volume. So because we are going to use files. And in here, I divided this in 3 stages. So here in the first one, compressed is the raw data that we get from the API, and then they converted to Parquet. And now I will explain what this station sync stands for. So in order to perform the data processing, there are different kinds of workflows you can implement here in Databricks. So there are some that are more specialized in pipeline ingestion and also in ETL. In our particular case, as we have already downloaded all the files, all the raw data, we are going to implement a job, which is a more generic processing workflow. So in our case, this is going to be our starting point with the pre-processing workflow. Here you have a dashboard in which you can see all the execution, the one that failed. You can enter here and see what happened in each of the executions. And and here you have the definition of the tasks that compose this workflow. So in order to make a pipeline. Well, the first stage for this for data preprocessing is the compress. So unzip the files and convert them to Parquet files. Here, this task, in order to configure the tasks, you could do it with a Python script. You can also select a notebook, a wheel. There are many different ways of defining a task. In our case, both of the tasks are scripts. You can also set dependencies. So here, for example, this task could depend on this one. And whenever you execute the complete workflow, it will start with the compress. And then, for example, if you have more stages in this workflow, then it will execute them in the order you set the dependencies. So we will go back to our PowerPoint. And our next stage for the data preprocessing will be, well, we are going to have different features from the raw data. The one that is of our interest would be free docs. So all the within the station, how many spots are free to leave a bike, and the raw data is composed of asynchronous events. So whenever it is left a bike or it is picked a bike, there is an event with a timestamp, and all these events that we could see on this plot has to be converted to synchronous data. So it needs to be resampled. In our particular case, we are going to sample it. We will have a sample rate of 1 per hour. Well, yeah. So after this, we need to clean the data. We have a status feature in the from the raw data. So whenever the station is not active, we remove all that data in which it's not active. We remove not valid data. For instance, if we have free docs with negative values, we remove periods of inactivity, and so. For the feature engineering, the strategy that we are going to follow is a hierarchical approach. So in this session, and what I have implemented so far is the prediction of the station that is just in front of the office of Plaza Catalunya, which is the 63. Here you could see in the map. And we are going to have as input feature for the model the free docs from the surrounding stations. So to capture the dependency of the proximity of the stations in order to predict what is going to happen in the future. I also added timing features. So I added hour of the week and the month. Well, I'm going to stop here and switch to Databricks, and I will explain this later because I wanted to execute some parts of the code, and otherwise it's not going to. I'm not going to have time for it. So for the training and the featuring and training process, I did a different approach than the workflows. I did it in a notebook. And here I just executed the import libraries so that it was already the cluster was already connected and initialized. So here in this part of the code, I cleaned the data. As you can see here, all that is not out in service or negative values and also inactivity. So if there are 24 hours of inactivity, I remove that data because it's useless for the predictions. And I will be executing this notebook back and forth. So here in the timing features that I implemented, there is important transformations that need to be taken into account in order for the model to be trained properly. So, for instance, the time feature of month or hour, it looks like this, like a ramp. So whenever you reach 12 in month, you will go to 1, and this jump is a bit misleading for the model. So the best approach is to modulate it so that the values that are contiguous but have a very big jump are contiguous also as a feature. Here in this part of the code, I perform this feature extraction. I will execute it also. I will leave it running. But sorry. Well, Then we need to define what is the input of the model, the X, and what is the Y. So the X would be the free docs of the inputs that of the other stations that we see. So here, the timing, and the Y is going to be the free docs of the station. The lag is going to be the number of steps that we give the model for predicting the horizon. And we are going to have 24 hours of lag and 24 hours of horizon for this particular case. We also have to apply data scaling. So the models need data that doesn't have an offset. So we have to remove the offset. And also, they work better if the standard deviation is 1. So, so we apply this scaling for that. Let's see if it's still some time to finish. We also perform a data split. So we use some data for training and we use some data for validating that this training has been performed well. And also there is another part which in this particular case we are not going to do, but we are going to use live data in order to test the models that we train. So and this data split is not something trivial. So we could end up with leakage, which is something that I will explain later in Databricks. So I will go back to this slide and imagine that we have the first row as test and the second row as train. That would mean that we would have 24 samples of X and 24 samples of Y overlapping. And that would make the validation be better than in fact it is, because in fact it's just applying a shift of samples of what it was trained with. So in the end, it would make the validation, well, it would be misleading because you would see something that is not what is going to be in reality. Okay. So another thing that that needs to be taken into account is also the architecture of the model. For this case, that is a time series problem. I have used LSTM, so long short-term memory. These kind of neurons are very suitable for learning dependencies between long training sequences, and that's why I choose it for here for this case. We also have transformers. Transformers are the architecture that is used in LLMs, and they have shown that good performance also for time series, but they are more complex to apply. And for this case, I didn't use it. And CNNs also are good, and I have used them in combination with LSTM. Let's see how is. Okay, so now we finish this part of generation of SY. Here we will use we will implement the scaling. So with a standard scaler, and also we would split the data. Here, as you can see here, I used a period of 8 multiplied by 24, so this is hours. So that's trying to minimize the overlapping of testing and training, and also not having like a period in which I always have weekend days for testing, and so that it's more or less I mean so that it has different kind of days, each for training and for testing. And now here the training takes place. So in order for MLflow to capture all the artifacts, metrics, and the model, and so on, we need to use this context manager of MLflow. Here I will add a demo name so that we can see it afterwards, and I will execute it now. I added just one epoch so that it takes short and we can see it afterwards. Well, here what we will see afterwards is we will see a loss and a validation loss curves. The loss is how the training data set, how good we get through this training with respect to the training, and the validation is with the how good it is with the part of the data that we set for validation. And afterwards, we would do a model deployment. For the model deployment, we have seen already the part of the part of tracking with this context manager that we added in the notebook. In this context manager, we will later see the artifacts, we will see the metrics, we will see what is stored in order for this to then keep track of the models, and then deploy the ones that are best, and so that is everything handy and easy to track. This is still ongoing. Let's see what we get out of these trainings. So we go to experiments, and here in training model, we can see the different experiments that I have taken. The first one is the one that we already launched, so it's still ongoing here, created 1 minute ago. And here we can see the metrics for all the experiments that we have performed. So we can see the loss curves, the bad loss curves. What I wanted to show you here with respect to the splitting of the data, which is something that I faced through this machine learning project, is that if we split the data so that it has a big overlapping, the training with respect to the validation, we can see that we get this nice value loss, but when you try it on data that has not been trained with, you don't see that good performance. So this is in this case reflecting a data leakage in the training. So apart from that, you can see here that on the right column, we can see that in models, there are some of them that has an icon here. So the ones that has an icon are the ones that were successful and generated a binary model. If we enter inside, we can see here, well, the model schema. So we can see we have 8 features with 24 samples with the 24 hours of lag, and just one feature of 24 samples of horizon. Here also we can see the requirements that needs in case we want to deploy this model, it has all the relevant information. So the Python version, we have the conda YAML, and all the necessary stuff needed, the YAML of the model with all the relevant information, with the signature for the inputs and the outputs and everything. And well, let's see how if it's still, how is it going? So now we have the demo already executed. It generated a model here. So now what we can do here is register this model. So if we want to keep track of different, let's say that we consider that this model has a good performance. Right now, I only executed with that one epoch. So we have just one value here for loss and bound loss, but let's imagine that we encounter that this is a good model. So let's register it. I already registered two models. So with two different architectures, we can create a new one, or we can add a new version for one of them if they are compatible. As they are compatible, we can register it here. And we will see in the experiments that we have here now this LSTM basic 2, so the version 2 of this first model that was trained some days ago. So now the next step would be, well, let's deploy it. So in order to do that, we go to the serving, to this serving, and create serving endpoint. We set a name here. So first, for instance, demo. We select the model. And now here we can select either first version or second version. Here we can select the compute type. Well, so some settings for the deployment. And what we have here, and we click to create it, and now we start the deployment. Let's hope that we have enough time for seeing it deployed. It takes some time, but yeah, let's see. So now we are going to test the model that we have deployed. We already have, I have already two models deployed. So the architecture that I have to, in order to test it, is an application in Streamlit that gets historical data from a Azure function service that gets data from SQL. This database has been populated by another Azure function that is time trigger every minute, and that gets live data from vSyn. Well, this part has stopped working some weeks ago, some months ago, in fact, and I couldn't solve it. So right now, we will make the demo with all the data that was stored in the past, and then we get the historical data and the predictions from the models that are serving are deployed in Databricks. Let's go to the application. Well, here we can see the map of Barcelona with the different vSyn stations. You can select the one that you want, and you can see the historical data and the current status. Right now, we are getting data from February, as it is not working the live retrieval in Azure. So we are going to pick the station for which we have implemented the model, and we are going to get the prediction. Well, right now we can skip part, and we are going to get the predictions. I just executed some minutes ago, but for economy reasons, Databricks stops the service and starts it again when you make a new request. And if you don't make request in some time, it stops the service. So we can now see here we are using this one, and now it will take a couple of minutes to answer. We can see here all the latency, the request, some statistics of the deployed model. And as you can see here, I executed it some minutes ago. And the first one had a latency of almost 2 minutes. And afterwards, the subsequent requests were just some milliseconds. And here requested rate, CPU usage, and everything. And now we have the prediction taken here. And I'm going to remove. So here we have the free docs and the prediction of the model from Databricks. You also I also implemented, the one in Databricks is not working very well, but I had one from the past that is working a bit better. It has a better performance. I didn't do in Databricks, so something in the middle didn't work that well, but I didn't have the tracking of this model. And you can see here a local execution. As last thing, what next steps could be done to improve this? Well, we can add more features. We can have more data inspection or ensuring quality. Also, it would be nice to have a testing after training so to have a better criteria for a benchmark. Right now, the scaling is is performed locally in the application, but it would be nice to be isolated, so to have it on the deployment. Well, have a common library. Well, many things could be done in order to improve this approach. Well, I hope that, and that's all. I hope that you like it.